friends, I am Kamlesh Parihar, Associate Professor, Civil Engineering Department, Jodhpur Institute of Engineering and Technology, Jodhpur, Rajasthan. Today, in this video lecture, we are going to discuss a numerical on conjugate beam method. Friends, in the previous lecture, we have discussed the theory of conjugate beam method and a numerical. So here we are going to take a complex numerical which involves some complex calculations. So what the question is, as you can see on the screen, there is a simply supported beam A, B, A and B, and EI is constant for this beam. There is a point load W acting at the center point C at distance A from the support A and at distance B from support B. Now what I have to find out? First I have to find out the slope at supports, that is theta A and theta B. Slope means thetas, theta A and theta B, and deflection at point C means at the point C. Remember, this C is not the center point. This C is not the center point. So I have to find out YC in this conjugate beam. What extra I have to find out? I have also to find out end at center. It means I have also to find out the deflection at center, and it is given that assume A is greater than L by 2. So this A is greater than L by 2. Okay, so center is somewhere here. Now I have to find out these values at this center point also. Then he has said that also find out maximum deflection in the beam. What is the maximum deflection in the beam? So maximum deflection always occurs somewhere near the center point. Okay, so these are the quantities that I have to calculate. I repeat, I have to calculate theta A, theta B and YC, then the deflection at center and the maximum deflection in the beam. So the maximum deflection occurs somewhere near the center. Okay, so let's start. As you all know, the conjugate beam method, what we have to do, first of all we have to solve the real beam and draw its bending moment diagram, and then what I will do, I will load the conjugate beam with M upon EI diagram of real beam. So this is the bending moment diagram of real beam. Okay, so this is the triangular shape. Now conjugate beam. Okay, so this is the conjugate beam as shown, AB again, and the BMD is now acting as load on this conjugate beam. So this conjugate beam is having a triangular load. Okay, and we have to find out shear force and bending moment in this conjugate beam, and these shear force and bending moments will be the slope and deflection in real beam. Okay, now to ease the calculation, to make the calculation easy, what I am doing is that these two triangular portions I have divided them. So this is the portion number 1 and this is the portion number 2. So the load of triangular portion 1 will be W1 and the load of triangular portion 2 will be W2. Okay, and the centroid of a triangle, as you all know, it lies at 2 by 3a. Next, now first thing we have to find out the reactions. Now how to find out the reactions? You all know there are two equations to find out the vertical reactions. Number 1, summation V equal to 0, and number 2, summation M equal to 0. So here I have applied the equation summation M A equal to 0. This equation summation M A equal to 0, this will give me reaction R B. Okay, so you all know how to apply this. To simplify it, I have calculated the loads W1 and W2, and I have also find out the centroids XA bar and XB bar. Both these centroids are from A, from support A. These are very simple geometric problems. Now, what is the load? We all know that load is always the area of loading diagram. So I have calculated the area of this loading diagram. What is the area? These are triangles, so area will be half into base into height. So what is W1? W1 will be half times A multiplies by height. So here I will get W1, that is WA square B upon 2EIL. This is W1, and similarly we will find out W2. This W2 is what? WAB square upon 2EIL. So W1 and W2, the loads of two triangular shaped loads I have calculated. Now our problem has been simplified. So this is the simplified model of our problem. That is, there is W1, there is W2. So I replace the triangles by W1 and W2, and XA bar and XB bar, these are the centroids. Now applying the equation summation m equal to 0, I have found out reaction RB. You can see the equation W1 XA bar plus W2 XB bar minus RB times L equal to 0. This is summation of moment about point A equal to 0, and from here I have found out RB. So what is RB? This simple mathematics and calculations. It is already provided to you in the notes, so you can see the calculations, simple mathematics. And finally I have found out the reaction RB. What is RB? Here RB is found out to be WAL square minus A square upon 6EIL, and similarly RA is what? WBL minus B square. It must be L square minus B square upon 6EIL. So RA and RB we have calculated. Now what we have to find out? The first part, that is slope at A and B. Slope at A and B means theta A and theta B. Okay, so at support we all know that shear force is equal to the reactions. At support, shear force is equal to reactions. So this is shown here. Reaction RA is there, and this is equal to shear force VA, and it becomes WBL square minus A square upon 6EIL. So this is theta A, that is WBL square minus B square upon 6EIL. This is theta A. So here theta A has been calculated. Similarly, either from analogy or by solving, you can find out theta B. So what is theta B? I have found it here. You can also do it, is simple mathematics. Theta B is what? WA L square minus A square upon 6EIL. So I have found out theta B also. So theta A and theta B has been found out. How? By finding out the shear force at supports. Now next, deflection at point C. Remember, C is not the center point. C is the point at which point load acts. So how to find out the deflection? Simply the bending moment at C will be the deflection at C. So bending moment MC is what? This is the simplified model. I have shown it here again for your easiness. RA multiplied by the lever arm A minus W1 multiplied by A by 3 lever arm, that is force into lever arm. So this has been shown here, RA times A minus W1 times A by 3. And again, it is very simple mathematics. You can solve it. What you will find out, that MC, that is moment at C, it is calculated to be, these are the steps of these calculations. And what I finally calculated, I finally calculated MC as WA square B square upon 3EIL. So this is my answer, MC, and this MC will be equal to Y at C. Okay, so what is YC? that the deflection at point C is equal to moment at C in conjugate beam, and it is equal to WA square B square upon 3EI L. Okay, so I think this portion is clear to you. So first part we have solved. Now second part. What is the second part? Deflection at center. It was given already in the question that this A is greater than L by 2. This A, it is greater than L by 2. It means the center is not at point C but somewhere before C. Say this point is D, where the center is there. So the center point is D and the ordinate on load is D1. Okay. Now what if I have to find out the deflection at this point? Again, I will calculate the bending moment at this point. So the bending moment in conjugate beam will give me deflection in real beam. So how to find out bending moment? It's again very simple. The reaction RA acts upward. This is the reaction R, 8x upward, and then there is load W1 dash. Now this W1 dash is slightly smaller than W1. This will be less than W1 because W1 is the load of this total first portion of triangle. So now I have to find out W1 dash also. So how I will find out W1 dash? W1 dash is the area of the triangle, and by using the property of similar triangle. So here, using the property of similar triangle, I have to find out, first I have to find out D1, D, and then by finding out D1, D, I have found out W1 dash. So this is W1 dash, and it is coming out to be WBL upon 8EI. So what is the WBL upon 8EI? This is the area of this triangle. As you are seeing this area of this triangle, it is what WBL upon EI. Okay. So what I have done, I have repeat again. First I have found out D1. D1 is found out by similar triangle. Which similar triangle? This similar triangle A C1C and A D1D. From these two similar triangles, I have found out the value of D1D, and then I have found out the area of this A D1D, this triangle, smaller triangle. So this one will become W1 dash. Now finding the moment at C. How you will find out the moment at C? Very simple. I again make the model just to make clear to you. This is reaction RA, and this is the point L by 2 distance, and this is the portion of load which is acting, that is W1 dash. Okay. And what is the distance? You tell me. If this is L by 2, then this will be 1 by 3rd of L by 2. Okay. So here I have found out the bending moment at L by 2. What is RA times L by 2? That is the force into lever arm, reaction into lever arm, minus W1 dash multiplied by this lever arm. There is 1 by 3 of L by 2. Okay. Now it's again plain simple mathematics. On solving, what you will get? You will get that y at L by 2 is what? M at L by 2, and it is coming out to be WB upon 48 EI 3L square minus 4B square. Okay. So this portion is also over. This is our answer. Now what is the left? The last portion. There is the maximum deflection. Now this is very interesting part. What is the interesting part is that the maximum deflection will neither occur at point C, neither at center, but somewhere near this portion. Maybe here, maybe here, maybe here, maybe here. We don't know where the maximum deflection is going to occur. So maximum deflection means maximum moment. So I have to find out maximum bending moment in this beam, and this maximum bending moment will be the maximum deflection. Now how to find out maximum bending moment? Very simple. What we do? We always do dm by dx equal to 0. For maximum bending moment, we do dm by dx equal to 0. And what is this dm by dx? We all know dm by dx is what? Shear force. that is dm by dx is equal to shear force. Now if this is equal to 0, it means this must also be equal to 0. So the point where shear force will become equal to 0, at that point bending moment will be maximum, and that will be the maximum deflection in the beam. So how to solve it? Let us assume that at a distance d from support A, the maximum bending moment occurs. So at this point shear force is 0. So let us equate shear force this point equal to 0. So what is the shear force at this point? The shear force at this point is what? We know that RA is acting upward, and this W1 dash, it is W1 double dash, it is acting downward. So what is shear force is what? RA minus W1 dash. This is my shear force, that is RA minus W1 double dash. This will be my shear force V, and this has to be 0. It means this should be equal to 0. So same I have done it. Now you also need to know d1 d2 in this. You also need to know d1 d2. So what is this d1 d2? Again, from similar triangles we can find out that C1C we know that C1C upon d1 d2 is what? A upon d, from similar triangle, and here from this similar triangle we can find out this value. So I have found out this value d1 d2 also from similar triangle. So here it is calculated from similar triangles. This is the calculation, and here I have found out W1 double dash. So when I will equate W1 double dash equal to RA, because RA minus W1 double dash is the shear force and is equal to 0. So what I will get? I will get that W1 double dash equal to RA. You equate both of these, and the solution from this equation, what I will get? I will get the distance D. I will get the distance D. Okay. So this distance D has been calculated. So D is the distance at which the shear force will be 0. At which the shear force will be 0, and that is the point where the maximum deflection is going to occur. So now let us find out the bending moment. What is bending moment at that point? I again draw the diagram for you so that it becomes easy. So this is the point where the maximum deflection is occurring. This is the load W1 double dash. This is RA, and this distance is D. Now we know that the center of this triangle will be at 1/3 D. So what is the bending moment at this point? Moment is what? RA times D minus W1 double dash times D by 3. Now we know that RA and W1 double dash both are equal. So let's take them common. This will greatly simplify our equation. So I have taken them common, and it becomes RA times D minus D by 3. That is RA multiplied by 2/3 D. Simply put the value of D as calculated above, and what we have found? MD max. That is the maximum bending moment. And what is this value of maximum bending moment? So this is the maximum moment that we have calculated. This is coming out to be MD max equal to WB bracket close L square minus B square to the power 3/2 upon 9 EIL upon root 3. This simple mathematics, you can put the value and you can solve it. And this is what? Again, Y max. It is written theta max. Sorry, it's not theta max. It's basically Y max. It's Y max. So what is Y max? Is equal to MD max equal to WB L square minus B square की power 3/2 divided by 9 root 3 EIL. So here we have got the answer. and the question ends here. Okay, so you please practice this question. If you have any doubts, you can ask me, you can message me, and please like and share this video. Thank you very much.